Hello, students. Today, we will start to learn the basic requirements of the BZT. First of all, the first basic requirement is to ensure that the standby power supply and standby equipment are put into operation only after the working power supply and equipment have been disconnected. That is to say, the standby power supply and standby equipment cannot be put into operation without disconnecting the working power supply and equipment. Why? Before closing the standby power, circuit breaker first ensure that the original operating power supply and equipment are disconnected to prevent putting the standby power supply or equipment on the point of fault. So, why did the working power supply and equipment disconnect? First of all, there is a fault, so the protective device will act to disconnect the work power and equipment. If the operating power supply and the equipment are not disconnected, the point of fault is not isolated. If the standby power supply and standby equipment are put into operation at this time, the standby power supply or equipment will be put into the point of fault, and the action of the BZT will fail or even expand the fault and aggravate the damage of equipment. So, first of all, make sure that the original working power supply and equipment are disconnected, and that this point of fault has been isolated before we can put in the standby power supply and the standby equipment. So, how do we do it? BZT should follow the logic of tripping the main supply. First of all, to the original working power circuit breaker issued a trip command, and then jumped once and captured the working power circuit breaker in the tripping position. After confirming the jump open, and then go to the standby power circuit breaker closed. The second basic requirement is the voltage on the working power supply or equipment disappears regardless of the reason. In addition to the blocking signal, the BZT should be operated. Why does the voltage disappear? In the case of a fault, such as a faulty line, a faulty transformer, etc., the protective device will act to disconnect the working power circuit breaker, and the working bus will lose voltage. At this point, it depends on whether there is a blocking BZT command and whether the BZT action conditions are met. If there is no blocking signal and the conditions for BZT option are met, then the BZT should be operated. The judgment for the loss of working power of the BZT, in addition to the working bus without voltage, but also to confirm that the working power line is without current. Because under normal circumstances, after the circuit breaker of this line is tripped, this bus loses voltage, and there is no current in this line. If the bus is captured to lose voltage, but there is current on this line, then what could be the situation? It could be that the bus PT is disconnected, causing the BZT to misinterpret the bus as having lost voltage. How to prevent misjudgment? We then introduce the condition of whether or not there is current in the line of the working power supply. If there is current, we block the BZT. In addition, we have external blocking signals, such as the operating duty personnel manually disconnecting the circuit breaker of the working power supply. When the BZT receives a manual tripping command to be turned on, the BZT should be blocked. That is, the BZT should be out of action, which is the need of the operation mode. How can we realize that the BZT should have a separate low voltage? This can be achieved with the starting part and the blocking open access. The second basic requirement. The BZT should be guaranteed to operate only once. Why only once? When the point of fault is a permanent fault, then the protective device action to trip the circuit breaker to isolate the fault. But for various reasons, the fault point is not out of the circuit breaker. When cut out, due to faults, the working bus voltage will be pulled down and will meet the conditions of the BZT operation. The first time the BZT operates, the standby power supply is put into operation. At this time, since the fault point still exists, the protection device on the standby power supply operates quickly to trip the circuit breaker of the standby power supply, and the voltage of the bus bar decreases again. If the BZT operates again and puts the standby power supply into operation, since the fault still exists, the protection will still operate and the voltage will not be restored, which means that the BZT will not be successful. This will make the grid shocked by the fault current again. Only harm, no benefit. And will expand the scope of the accident, damage the equipment. What can be done to make the BZT operate once? Control the closing pulse of the standby power circuit breaker to operate only once. 4. The BZT should not be operated in the case of an internal fault in the power system that causes the loss of both the working power supply and the standby power supply. Why? Because the working power and standby power disappear at the same time, even if the BZT operates, cannot play a role in restoring power supply. If the BZT operates, the circuit breaker of the standby power supply closes, and the circuit breaker of the original working power supply is disconnected. When the fault is removed and the power supply is restored, all the loads will be supplied by the standby power supply, which may lead to overloading of the standby power supply and reduce the reliability of the power supply. Therefore, when the fault is removed and the power supply is restored, the load should still be supplied by the original respective working power supply. So, the BZT should not be operated when the working power supply and the standby power supply disappear at the same time. And how do we do that? Thus, the BZT has a standby bus voltage monitor. 5. The operation time of the BZT shall be such that the outage time of the load is as short as possible. Why? The so-called BZT operation time is the time from the work bus disconnected by powered side circuit breaker, the work bus voltage loss to the standby power supply into the work bus to restore the voltage. That is, the user's power supply interruption time. Outage time is shorter, the more favorable to the user. So, is the shorter the better? Of course not. For example, when the working bus is equipped with a high-voltage large-capacity motor. After the worker bus power outage, due to the motor back sending power, the worker bus residual voltage is higher. If the BZT operation time is too short, it will produce a large inrush current and inrush torque damage to electrical equipment. In addition, the time for BZT to be put into standby power should be longer than the longest external fault removal time, because before BZT operation, the external fault has been removed and the BZT operation will be successful. Therefore, considering these circumstances, the operation time should not be too short. Operation practice has proved that in the case of there is a large high-voltage motor, BZT operation time to 1 to 1.5 seconds is appropriate. Low-voltage occasions can be reduced to 0.5 seconds. 7. The automatic load-shedding function of BZT shall be verified for overloading when the standby power supply and standby equipment are automatically put into operation, as well as for self-starting of motors. If the overload exceeds the permissible limit or cannot guarantee the self-starting, there should be automatic load reduction measures when the automatic input device operates. 8. Accelerated tripping function of the BZT. When the automatic input device action, such as standby power supply or equipment put on the fault, there should be protection to accelerate the trip. The protection device action time is relatively short. Alright class, that's all for today. See you next class.